Okay, gentlemen, let's look at the first section of Chapter 0, and we'll get an introduction to real numbers. So looking at our notes here, it's pretty self-explanatory to follow with these definitions, but just to go through them quickly, the major first group is real numbers, and that includes everything that we're going to talk about. Repeating, negative, radicals, rational numbers, fractions, everything. So that's this entire group. Not only the natural, the whole, the integers, the rational, irrational, it's everything. It encompasses all of those categories. Next, natural numbers is kind of the most specific type. That would be this group right here. So the innermost circle. It is counting numbers. So it's if you were to start counting an object in a group, 1, 2, 3, 4, 5, and so on. The next group would be whole numbers. Whole numbers is all the natural numbers plus 0. So it is, if you look at the group in here, it's all the natural numbers plus the only additional number is 0. So it encompasses natural numbers and is one group larger, including 0. Next is integers, which is everything natural and everything whole plus all negative numbers. So it includes natural, whole, and negative numbers, and that's called integers. And you can see in this group right here, it just continues to include the circles inside of it and get slightly larger. Next is rational numbers, and rational numbers are anything that are fractions, as it says in here, can be written as a over b. A over b are numbers, and as we know, you cannot divide by 0. So it's a and b are integers, so positive, negatives, everything, and the only rule is that b cannot be negative. Okay, and how you say that is a divided by b such that, that's that vertical line, such that a and b are integers and b is not equal to 0. And we can see that's everything that we have talked about. Natural, whole, integers, and irrational. That's all of those things. Still, all of that is still included in real numbers. Right? And then we could see irrational is everything that's not rational. So all these repeating decimals, pi, a radical that we don't know the answer to, those are all irrational, but they still fall in this full group called real numbers. That's everything. All of these things are real, and then there's specific categories. Irrational fall out of that group, but still real, and then everything kind of builds from natural upwards to rational. Okay, an important fact about real numbers is that between every two pair of real numbers, there is infinitely more real numbers. So you can always essentially like zoom in and find another real number between any two real numbers. You can continually find another real number between any two real numbers. Okay, our next thing is you either have, if you have two real numbers, one's larger, one's smaller, or they're equal. Those are the only three things that can occur. And if one's larger, you can find one in between a and b. You can always find a number between a and b. Okay, important facts about real numbers. We see here stuff we probably know from 8th grade, just our regular inequalities. A is greater than b, meaning that if you were to subtract a from b, since a is larger, you would get a positive number. 5 minus 3. 5 is greater than 3, so it's a positive answer. And you would say that is a is greater than b. Same for less than, except it's negative, because now you have 3 minus 5, or 3 is less than 5, or a is less than b. A is greater than or equal to b, meaning that they could be the same, so you could get 0, but it's if not, you're going to get a positive answer. A is greater than or equal to b, and then a is less than or equal to b, meaning that it's smaller or equal to, so you're either going to get negative or 0. Very simple things we probably know already. This is slightly new, I assume, for most of you. Right? Interval notation is something we have not seen, but that is the most important thing from this section here. Interval notation is what we're going to use whenever we talk about domain. We're always going to phrase it in interval notation. So now that I'm sure inequalities are familiar, we're going to bridge the gap between inequalities and we're going to use interval notation. So we get familiar with it, and then that's what we're going to use all the time. Okay? So as we could see here, if we have a is less than or equal to x, which is less than or equal to b, we will use hard brackets. So hard brackets are always used when we have or equal to, right? So if you're including that endpoint. If we have two soft brackets here, A, comma, B, it almost looks like an ordered pair. That means A is less than X, which is less than B, right? So they're both soft brackets, open brackets. They do not include A and B. They won't be equal. Okay, and then if you have some sort of a combo, half open, half closed, whichever letter or number has the hard bracket, as you could see in the third example, A has a hard bracket, so A is included in that, and you would color that in with a dark circle, right? And then the same thing on the other side. B, if that has a hard bracket, that one's the less than or equal to, and that one would be colored in with a hard bracket. The soft bracket ones would mean that it's not included, so it's like an open circle covering those endpoints. Okay, and we'll see examples of this down below, but those three interval notation are extremely important. Unbounded ones, all this means is you don't have the other endpoint, right? Unbounded on one side. So you have infinity, it goes on forever in one direction. If we're going on forever to the left of a number line, we call that negative infinity. So you're going all the way towards infinity on the negative side. And then obviously infinity on the right-hand side, meaning everything going to the right. Right? And the order of this interval notation does matter. The order of that does matter. Okay? And same rules apply if you have a less than, you would use an open circle or a curved bracket. If you have a hard bracket, that means you are including the endpoint, and that means it would be a colored in endpoint. And then same up above, where now you're just shading the other direction. It's greater than, so it's everything to the right. And it would be including, the endpoint would be or equal to, and then not including would be just less than or greater than. Okay? Now you always use a soft bracket around the infinity. All four of these have a soft bracket around infinity. Always. Why? Because you cannot include infinity. Where does infinity end? How do you put a pinpoint on infinity? We can't do that. Okay, so you will never, ever see a hard bracket around infinity. Okay, and we see some of those things highlighted down here. Hard brackets are for closed sets where you include the endpoints. Soft bracket are for open sets where you do not include the endpoint. Okay, and it says there we will always use infinity with soft brackets. Okay, so we see here x is greater than or equal to 5, and that would tell us that we have a 5 that is included, and it is always greater than x is always larger than 5, so we go towards infinity and we close it off with a soft bracket. So 5 including 5 and everything to the right, everything going towards infinity. So this is what your number line would look like. Some people use the this symbol right here. You'll go like this sometimes on the number line. That's fine too. Some of you have seen it with a closed circle including the 5. That works as well. But there's our number line representation of x is greater than or equal to 5. Interval notation in green, hard bracket 5, comma, infinity, soft bracket. Always soft bracket on the infinity. Okay? Here, 4 is greater than x. It's sometimes easier for us to see it as x is less than 4, right? So 4 is always greater than x, and usually we try to write it such that the x is on the left-hand side, and then we just reverse the symbols. X goes here, 4 goes there. We flip the symbol. X is less than 4, so we're always below 4, but we never get to 4. We're always below 4, but we never get to 4. So there's our number line. You do not include the 4. Sometimes you'll see a soft bracket as you see up here, a soft bracket like that. But it's an open circle on 4, not including 4. Very close, but not including 4. So there's our interval notation. All the way towards infinity on the negative side, always a soft bracket there. And we go up to 4, but we do not include 4. We go up to 4, but we do not include 4. So there's our soft bracket there. And here's the last example we'll do. -1 is less than x, which is less than or equal to 6. Right, so if we look at what this means first, I like to reverse it like this, just like we saw before. So we know that x is less than or equal to 6. And 1 is less than x, meaning that x is always greater than -1. right? Not including -1, but x is always greater than. So we're saying in between that. You're always greater than -1, and you're always less than or equal to 6. So 6 is your hard bracket, -1 is your soft bracket, and you're going in between them. Always larger than -1, but not including -1, always less than or equal to 6, including 6, right? So there's our shading. Hard bracket on the 6, colored in circle. Open bracket on the, or soft bracket on the -1, open circle, and here's our interval notation. The order does matter. You want it to match the number line. So -1 is more to the left than 6. That's how you write it in interval notation. Hard bracket on the 6, colored in circle on the 6, and it's including. Soft bracket on the -1, it's an open circle on the -1 because it's not including the endpoint. Okay, so those are our 3 examples. You have some classwork to do. Good luck.